Thank you for joining us. I'm Aditi, and I would like to welcome you all in this data science webinar organized by Institute of Advanced Sciences and EEE GSE. I hope all of you are doing well in these uncertain times. So today we have with us Mr. Akshay Seth, who is data science manager at Funnel, and he will be interacting with us on the topic, the power of data science and machine learning. Um, So Akshay is the head of data analytics and data management at Funnel. He works very closely with the product team to leverage artificial intelligence and machine learning capabilities. He's also responsible for streamlining the data collection and data management strategy for business intelligence. He also co-founded a cybersecurity startup which was named Top 30 Startups by Forbes India in 2016. Akshay has also spent over 5 years developing big data and artificial intelligence products for the fintech and healthcare sectors in Singapore and in India. He also brings experience from Singapore Diamond Investment Exchange, where he involved in quantitative and statistical research. He graduated with a Master's in Knowledge Engineering from National University of Singapore. Now, before Akshay takes over to begin this talk, I would like to remind all of you to answer a few initial questions as shown on your screen. And you can also see them in the Q&A tab on the on the right side of your screen. And also for the NTU students who need a seminar endorsement, remember to join this webinar with NTU based email ID and to fill in the survey form at the end of the seminar. Over to you, Akshay.
Thanks a lot, Aditi, for a quick introduction. Thanks everybody for joining the call. Hope you are staying safe as it's a very tough situation going around. But let's begin the webinar with understanding from where I'm coming from. So what exactly I am doing at the moment. So I'm coming from Funnel. What exactly is a funnel? Funnel is powering private capital market. What that means, Funnel is a private investment platform that leverages data and technology to power private capital markets. So we basically deal with sell and the buy side. So if some company who wants to raise funds, we deal with them and we deal with the investors. So we have 12,000 plus investors, and we have companies coming from SpaceX to a small company of a seed round itself. So we closely have successfully funded 45 company, which includes SpaceX twice and Grab, Gojek, and other companies as well. So all of this we do using technology and data. A quick understanding from where I'm coming from. I basically started my career as a computer science graduated. I worked in few companies in data science, where I was involved in the health projects. Then I had my own startup in security solutions, which was listed in top 30 startups by Forbes India in 2016. Then I did my master's, and I have experience of 5 years plus. I'm a mindfulness trainer and an ethical hacker as well. But don't worry, I'm not here to teach all of those today. It's basically to understand and give you a quick understanding how data can be utilized, what exactly data means to you and to the world. So I will start with a new quote, that is, data is a new fuel. Why is that? Because now if you see the current situation, what exactly is booming? In COVID-19, people are paranoid and people are staying at home. They are not able to go here, there. So they're not able to take tourism, flights, nothing, right? So there's no fuel being utilized. The gas and oil sector is struggling with it. But have you ever noticed how much data we are collecting now? everybody, even today, we are having a webinar. It's also a data to us, isn't it? So data is becoming a new fuel. We need to understand what exactly data means to us. So before we begin the seminar, let's try to understand why exactly you are here for. So Aditi, can you please provide me what people are here for?
Sure. So we have some interesting answers, such as I want to know how it can be applied to my field of study. Another person says that I'm here because data analysis makes up for half my work. So another person says everybody is talking about data science because I want to learn how to interpret information. Okay, another interesting one. So I won't be unemployed in the future.
Okay, that's a quite, I would say, diverse people, in fact. So coming to learn about data, understand how data can help us, how data can provide you jobs, and also how data is being booming nowadays, and why exactly it is booming now, right? That is also a good question which we have to ponder upon. Okay, so we will keep it, stick to all these questions, whatever you are here, we will try to address within next 60 minutes so that once you go off the screen, you understand what data can do, how you can build up your skills, and where you can apply your this data skills in your current day-to-day work. Okay, perfect. Let's go to the another question, which is what you mean by data and what is data science to you?
So somebody has answered that data is a set of variables generated by observations or experimentation.
Okay.
Another one is, okay, deep learning can offer predictions in many applications.
Okay.
Okay, so this is basically a question and an answer. So he says, however, it is a black box and we do not know how these predictions are made. Do we have any way of finding out? Well, you'll know as the talk proceeds.
Yeah, sure. We will give you a quick understanding how data science can help you to understand those things, and also how it has boomed. So you will get to know about that. Yeah. Okay. Anything else?
More, yeah. Another answer is, I suppose that data science is important. Without the proper skills and tools to process the data at hand, no matter the amount of data one has, it amounts to very little. Okay. Data science plays an important role for every industry. Thus, we should all continuously learn more about it.
Yep, that's true. We will have a few case studies how data is utilized in Singapore by various industries. Yep. Okay. Thanks, Aditi, for a quick understanding what people understand about data and how data can be beneficial for them. Okay, let's try to understand what are the enablers of data, why data is now booming. So how things started, there was two laws. That was the first was Moore's law. What Moore's law says that every 2 years, the processing power will increase. So remember those times when we used to start a laptop or PC, it used to boot up in 2 to 3 minutes and we used to go and grab some food or drink water and we used to come back and then the laptop or PC used to start. Nowadays, how much time it takes? A blink of your second, the PC is in the desktop mode, right? That's what is the processing power I'm talking about. Coming from 19th century to 2020, where we have i7 quad cores, pentacore machines, huge servers. That's something how data has increased. So the processing power has increased and it is getting doubled every 2 years. Intel, Colloquium, all these companies are working very hard to reduce to come into the micro technology as well. So let's go to the another law, which is cadence law. What it says that every 18 months, very less than the Moore's law, the storage space will increase. What that means that Remember those times when we had a floppy disk and we used to save a single photo or two photo because it used to be 1.4 MB. Then we moved to a CD, DVD, Blu-ray disc, pen drives. But at present, around your laptop, do you see any pen drives? Do you see any hard drives? Where is all the data? It's on the cloud, on the servers. The storage space has increased phenomenally so that the data can be collected enormously. And these are the two laws which is holding truth at the moment and which allows data science to come into the picture. If we didn't have the processing speed, if we didn't have this storage speed, I won't be sitting over here talking to so many people because there would be a very technological gap. But now you can see that how things have moved, isn't it? Let's try to understand how we are collecting data, from where this data is coming from. Let's go towards the data. So data comes from 4 different partners or places, which is internet. It's a huge internet web where searches are done. Every company is coming global. Every company is creating their website, having e-commerce. You are sending mails, blogs, Twitter, social media. The internet is providing so much of data. And now Facebook has started Facebook shops. All the small petty shops, retail motor shops can create their profile on Facebook, on Amazon, and they can list their products. This is what COVID is bringing us, going digital phenomenally faster than before. That's the speed where we are at the moment. We talk about the speed as well, how much data we are collecting as well. And another is everything is being connected to devices. IoT has, I guess in last 10 years, everybody have talked about IoT, cell phones, barcoding. People are using scanning to at the fair price shop to register. You have QR codes. Even Singapore government smart nation project, every traffic light is connected to signals, connected to internet, dustbins, waste bins, cameras, everything is now being connected to it, to internet. That's what IoT is providing, and that is giving us data 24/7. Then huge amount of data is coming from research, as a lot of people, I guess in NTU is famous for research, isn't it? So many PhD people are writing journals or writing research papers. That's also data where you have experiments, findings, all that is a data to us. So data is not having a hypothesis. Data is whatever paper you are publishing is also data to the world, isn't it? Even space surveys, NASA, all the space companies are collecting huge amount of data, 200 gigabytes per night. That was like in 2000. How much it has increased now, don't know. That's amount of data we are processing it. And enterprise, that's a bigger data what is we are getting at the moment. All the enterprise are going digital, all the products are coming up. But have you thought, okay, let's think, everybody is now having a Apple watches, right? What Apple is getting out of it? Selling a watch for $600, what Apple is getting? You are paying Apple $600 for what? Just to see time? No, na? You want to understand your heartbeat, when you want to drink water, your messages and everything. So that's what all the enterprise is collecting at the moment. And the best part of it, which you have never ever thought about it, that you are giving all your personal information, health information to Apple free of cost. Not free of cost after paying $600. How is that? Because your heartbeat, your BP, everything can be measured by the smart watches. and they know what time you are sleeping, they know what time you are peeping, you are doing everything has a breath, everything has a pulsation, everything has a pattern which data science can dig into and try to understand. At this time this guy is doing this without having a camera, just by your heartbeats and all that we can understand that data, what exactly you are doing at that moment. And what you are giving is free of cost to Apple, Google, all these companies. That's the enterprise level of data what these companies are collecting and publishing. Isn't it phenomenal? And after paying $600 and the data. Okay, no worries. That's a trend. Apple Watch are trend, Fitbit is trend. You need to understand your fitness levels and all that. So it's okay. Let's go further. Are we using that data or not? That's a bigger question comes to the mind. So we need to understand that all this data can be utilized to predict future. So there was a guy, I guess you have heard about Robert, rich daddy novel, right? So he had said that the best way to predict the future is to predict the past. Let's try to understand that how much data we are collecting every moment, every minute. So in 2019, we had so much of data coming in. So we had like 4.5 million videos being watched every minute. 4.5 searches being conducted every minute. Then we have 4.4 internet GB of data collected on internet. We had 1.7 million of Twitter swaps every minute. We had 18 million of texts being sent every minute. So much, we have 694,000 of minutes of hours of video being streamed every minute in 2019. That's amount of data we are able to know every minute, right? Using your cell phone. You can collect that amount of data just by a single cell phone. So imagine how much of data at present the world has. So data never sleeps. You need to understand it was predicted that by 2020, 2 MB of data every individual will be creating every second. What that means, 7 billion people creating 2 MB every second. Imagine how much of data we are having. And I guess due to COVID, it might move to 2.2 or 2.3 MB as well. Okay, let's move on. Are we using that data? That's the question we want to understand. We are collecting data a lot. We are trying to convert into information content, and we are not able to utilize it fully to convert into knowledge. That's the data challenge what current has, and everybody's talking about data because everybody knows that this will take up all the jobs because everybody requires data. Every job will be data driven. All the companies are moving data driven. Everything is now becoming tech. So that's what is necessary and it's important, which you need to understand. Another thing is that how much data we are able to collect and analyze is only 1%. That's the research done by IBM that only 1% of data we are able to convert into a knowledge. So we are able to utilize. So 99% of data is being junk or dumped or not utilized at all. So the utilization curve is a linear curve, but collecting data and having data is a exponential curve. Very much similar to COVID. No worries. Let's move on to understand how exactly we can use this data to convert into knowledge. What are the skill set used? Why data science? What can it can bring into the picture? So you need to understand the 4 V's before we move further. the 4 V's of data is coming in volume. As I told, that huge amount of data. So data is never resting. Data comes in many forms. So I guess there was some person who talked about that data is being hypothesis and all. No, data is coming in various forms, structured, unstructured. So text, web, images, video, audio, internal data, external data, or graphs, everything is the data. So data comes in volume, velocity, and variety. Velocity because huge amount of data is coming from the IoT, which is working 24/7, machines, drones, social media handles, and all that data is coming 24/7. So these are the 4 basic V's which enables data science to move further. But the 4th V is something which is important and which will take a time. What is that? That is veracity. What that means, data is in doubt or trust. So data comes, but there's a lot of time being spent in cleaning data. So the quality of data, what we are collecting, is not up to the mark. A lot of PhD people are doing their researches. If you ask them how much time they are doing the data analysis, is very less. How much of time they are transforming data and creating data in a good form, that's the major part of the time. So that this veracity is very important to make sure that data can build up the trust and we can have a data-driven society and companies as well. Let's move further, in fact, into analytics. We have talked about data, how data is coming, what data is all about. What is analytics? Why data analytics, data machine learning? There's so much of a booming thing. So let's try to understand the 3 pillars of analytics, which is descriptive, predictive, and prescriptive. Do you think that these all 3 pillars are coming now? Means it has been designed now, it has come now? Well, no, this has been there since ages. Companies were there, we have just revised the names. Descriptive is what basically it gives you the business reporting, dashboard, scorecard, data warehousing. People would have heard of data warehousing, data marts, and all that. That's what descriptive analytics is all about. Converting all that numbers and giving you what is happening at the moment. How much sales we have generated, how much is the revenue we have generated, how much product has been sold. So that's what we have done in last 10 years, 1 year, 1 month, all the time series you can apply, you can slice and dice the data. So this has been there, isn't it? Financial reports, a good example of financial reports, which basically gives you a yearly understanding that what businesses are doing, income tax statements and all that. That's what descriptive analytics is, converting the numbers into data. That's what descriptive is all about. Predictive is something new. That's what people are talking about, which is machine learning, deep learning, AI, all kind of jargons you can say. So we will go deep dive into predictive today. What exactly is predictive? And then there is the prescriptive. What prescriptive is? It has been there since ages. How I can tell you? Think prescriptive as a doctor. So when you go to a doctor and you basically tell your symptoms, right? So what a doctor is taking your data and based upon his knowledge. So knowledge over here would be some algorithms or some knowledge base you can create or a corpus, and what he's prescribing is what you should do. That's what prescriptive analytics is all about, which is utilized in optimization, decision modeling experts system. That's what people are using prescriptive, how they can prescribe to move further, to grow further. And predictive is all about predicting the future using machine learning, AIs, and all that jargons what we have. So far, we have gone through the data and analytics. Let's go deep dive into predictive side now. What is data science? As we have understood, people would be thrown out of jobs, but that's not the truth. Well, the truth is that all the people have to adapt data science to be in the job. That's what is important. So let's see how it comes up, how data science is in the middle. So if you can see, this exactly is the, let me change my mode. Laser, yeah, pointer. So if you see, this is the domain expert. So you can come from biology, you can come from arts, any department. This is your expertise, domain expert. And you might have to have few understanding of coding or hacking, whatever you call. It can be data preparation, transforming data. Then is a bit of data engineering required, but it is only required not for you. We will have to understand whether you would be the correct person to do the data engineering work or not. And you need to understand the statistical, understanding the models and how your hypotheses are coming for. And if you include the coding and statistic, you have a machine learning. And if you include your expertise, your domain expertise, then comes the data science. So no one would be thrown out of the job. The only thing is that you have to move yourself from statistics to understanding of coding as well. So that is the, you need to understand how you can develop those skills now. So far you have understood where data science sit in and how you can proceed over there, right? Let's move on into the data science. Do you think that all these things, data science and AI, is created now? Well, that's all the first, what you are hearing is not created now. It has been created since ages. Bayesian theorem, where machine learning uses Bayesian theorem, which was created in 17th century. Regression modeling is created in 18th century. Neural network was created in 1940. Everything what we are using was created way ago. Our scientists, our great grandfathers have created all these tools and understanding very ago. So you need to understand that there's something new what is coming up now. The only thing is that we have got good amount of data to use all these tools, techniques, algorithms to come up with the insights. So all these things has been there since ages, and we are just utilizing that knowledge now in this century, in this year itself. Let's move on to understand the jargons what we have. That is AI. AI is just nothing getting machine to do what humans are good at. So just giving machine to understand how they have to predict, how they have to understand and come up with a decision using data. Machine learning is something, is basically it's an algorithm which is being fed by data to predict something. We will go in details what is that something. And deep learning is also, it's basically a type of machine learning only. Just you are going deep diving into the unstructured data, text data, video data, image data, and trying to process those data. That's where deep learning comes into the picture, because you have to go into the multiple layers embedding and all that jargons and science and theories comes up. So understanding these jargons, let's go a bit more detailed now. So what typical problems usually you have day to day and how machine learning can help? So types of machine learning can be regression, classification, clustering, or detection. What regression means? Regression is simply you are forecasting a numerical value. You are forecasting that next 1 year, how many number of revenue a company will generate, how many number of uh, I would say COVID patients would be based upon the trend analysis. So that's what regression is all about. And classification is just dividing the data into two parts, into two classes. That is class A or class B. For example, if you have to buy an insurance, so the classification is whether the person will buy insurance or not, yes or no. That's what classification is all about. Clustering is try to understand a group of people, to understand what this group of people likes, attributes, and all. So a lot of people belong to some set based upon some trends using data itself. So it's only classifying those people together and grouping together and binning together. It can be supervised and unsupervised. And anomaly detection is basically, you might have heard of fraud, right? Banks have this problems where they want to detect what are the fraud transactions and all that. So you need to understand the outliers, and you need to understand those trends, which basically tells that this is a fraud or not a normal transaction. So these are the typical problems which can be solved using data science. Let's understand a supervised learning, what exactly a machine learning model is doing. So what exactly we do is take all the data, then we create features. What features is basically we are pre-processing it, transforming it, and if we have a supervised, we would have labels. What label is? We would have a target that whether this person will buy insurance or not. We will have last 2 years of data that those people who have bought insurance and who have not bought insurance. That's what is the labels all about. Then we give it to machine learning model. This algorithm, we don't basically go deep dive into algorithms. This algorithm has been created way ago. People are coming up with new algorithms and they're just fine tuning those algorithms and giving up on new names. Still, those methods remain true, those validation, those hypotheses, those techniques remains true, what we have based upon probability Bayesians and regressions and all that. It's only how they are tweaking to understand and come up with another algorithm. Then we basically come up with the prediction and we have the expected results. Then we have to have new data coming in to test so that we understand how our model is doing, how accurate they are generalized and all that. So this exactly is a good understanding for you how you can do a machine learning model. So far, good. Let's move on. This is what looks very simple, right? Is machine learning is simple. You don't have to spend a lot of time, a lot of energy into it. Go to some tutorial, understand the basics, understanding the concepts, and then deep diving into the tools. That's what is you need to do. So I'm providing you concepts, and then you can deep dive into those tools, go to documentations, and you can understand it. So what all are the tools? We have Python, Pandas, R, scikit-learn packages. So two main players are basically Python and R. These are the scripting of programming language. And you have packages, Panda, scikit-learn, Scala, Sparks, and all that other packages and all that technologies. And you can basically deploy in clouds locally using TensorFlow, Google Cloud Platform, Amazon, H2, Cafe, machine learning. So you have tons of things to try out, to play with. The only thing is to understand the data, understand the knowledge, and do it correct. Whatever you do, because if you give any garbage value to machine learning algorithm, it will give you garbage out. garbage in is equal to garbage out. It will not give you good results. So understanding data, business understanding. So we need to follow what has been there, which is CRIPS, and which is business understanding, data understanding, data preparation, then modeling, evaluation, deployment. So this is how exactly we have to move in the future itself. Right? Let's go ahead. Everything won't be done by a single person. If you understand the whole flow, that can you do it? No, it cannot be done by a single team. So that is why data science has different teams. That's what data scientist, data engineer, data analyst, and application architecture come into the picture. Now you need to understand where you fit in. So data scientists or data science people are basically preparing data, feature engineering, and modeling. Data engineering are basically creating data pipelines and data acquisition and creating those things. Data analyst is helping to clean and transform data. Application architecture is basically deploying all that data to production level. That's what AA do. Let's understand what each process, what we talked about, how these people play the role. So understanding business objective ID is basically done by DS and AA, then DE and DS is AA is to get data, train data and all that. Prepare is done by DS and DA. Training is done by DS. AA is only deploying, and updating data is important. So you need to recalibrate data because new data is coming in. So if we say that how much data we will collect in 2020, what we predicted using 2018 and 2019 data will be wrong prediction. Why? Because we have external factor like COVID. Due to that, people are using phone and online more. So the data would have exponentially grown. So we need to take data from January to May to understand the trend. So you need to update and recalibrate data. That's something very much important. Let's move on to understand the case studies and all that. So before we move on, you need to understand, do not forget the science in data science. Everything what we do is data driven. It has a logical explanation. You basically have a observation, hypothesis, experiment, analyze, report, and then produce and invite others to reproduce the results. That's what data science is doing. So my key principle for successful in terms of analytics, you have to follow 4 principles. That is sequential approach. There's no shortcuts, and you need to understand business model well. Data quality is important, which I talked about, and subject matter expert is also important. What people are coming from different backgrounds. So this is something important. You need to be domain expert to go deep dive into that field. So without theory, experiment has no meaning. So without theory, no one asks any questions. Without theory, there's no learning. So we have learned a lot of theory. Let's now go into the case studies, how this data is being utilized in Singapore by various organizations. So currently, if you see retail, they are using for targeting marketing, they are using for customer profiling, inventory management, in financial side, credit risk analysis, investment analysis, forecasting, CRM, insurance, fraud detection. So these are the various sectors where the data science can play a picture. And these are the basically, if you go through it, the 4 problems, the 4 type of machine learning, what we talked about is relevant. Either it is a regression, classification, clustering, or anomaly detection. All things remains true. Healthcare, customized care, fraud detection, diagnosing diseases, manufacturing in terms of anomaly and optimization. Government is using a lot of data. If you understand government is using drones to get to understand how people are walking and how people are maintaining social media distancing, that all the video data is being converted, and to understand who all are the people who are not maintaining the distance on real time, they are getting the alerts. So that's the data science is coming into the picture. If you go to Changi Airport, we are, I guess this year they had a plan to launch immigration using your face detection. So they can understand who you are using your face. That's what data science can provide. All the cameras has been so much intelligent that it can detect where there are collisions, accidents, fights, and they tell the society, they tell the police stations and all that. So Singapore has huge amount of tech-driven projects and which use data phenomenally well. So I would say that Singapore is a great example. E-commerce, no words to say that. You guys know about it. Search engine, Google. What you want to know, it would come in the top one page. Two, not one page, top three searches, isn't it? Previously, we used to go to search page one, page two, page three. Nobody goes to page two now. That's what search engine has done now. Let's go a bit more understand on the case studies. So if you talk about NTU tanks, they are using data science for customer analytics, understanding how they can do the marketing campaigns, how they can understand the trends, how they can forecast which inventory to buy, which when the toilet paper are getting over, when they have to get from the warehouse. All things are being used by FairPrice and tanks. Then if you talk about Best, you have also heard about this. It's an electronic giant, right? So they are also using for maintaining the inventory, what has to be required, optimizing the whole process, right from manufacturing to customer utilization. Then you have YG Marketing. That's basically it's a group of brands in Singapore, which are basically using for the whole supply chain to get the distribution right from manufacturing to warehouse to the sales to the retail stores. So even in the fashion industries also we are using data science. Isn't it great? Let's move on to understand what all things it can be done. In fact, PAP, our government body, is using data science to give to understand, to give better service delivery to Singapore citizens. As they mentioned that they're extracting data, slicing data, and dicing it to understand what a small child requires and what the neighborhood requires, what the elderly person requires. Based upon that, they are trying to understand the trend, and they are providing the best service. That is why Singapore is known as the best government policies and best bureaucracy, because they are using data-driven approach. They don't go on the gut feeling. They don't go on other things. They have a valuable thing. They create a data story which backed by data. Banks uses data phenomenally just to understand what you want to buy, which credit card you have to get. Huge amount of analytics is around financial side. If you talk from my company, we use data phenomenally to understand how SpaceX is doing, what we are predicting, how much lifelong that company has, what is the profitability, whether we have to invest, all kind of models, all kind of predictive models we are able to predict, and we are able to create in fintech space to understand that these are the potential companies. Understanding we are predicting potential companies, not the unicorns. That's something which is tough to predict. So that's what I would say, that I would finish it by just providing the quick understanding of case studies. Then we will move to the Q&A part. So the last two examples is Marina Bay Sands uses data science to optimize hotel revenue. Even casinos are using data science, that how they can not exactly who would lose and win, but how to do the cash flow cycle, and which table requires the coins and all that. Everything is being utilized as well. And for guests, they are using to give the better guest satisfaction experiences. DHL logistic partners are using to optimize routes, which will help to reduce the cost, the fueling cost and all that. So that's why data science is coming into picture itself over there as well. So that's what I would like to provide you for quick understanding related to data science. Then I would pass on it to Aditi for the feedback, and then we can move towards the Q&A.
Thank you, Akshay. Your talk was very helpful. We have quite a lot of questions. So the first one being, what is the first step for an absolute beginner who does not have any computing background to start in data science?
Okay, so I would say that the best way, if you are working professionally or working on some project, so take up that project, take up a data set, and just getting the concepts correct. You need to so you need to understand the quick understanding of the concepts, that what all are the algorithms available into the market, and deep dive directly into scripting. So you can use tools. I didn't mention about tools because I didn't wanted to promote some favorite tools and all that. But I would say that there are plenty of tools available. If you don't want to code, you can directly give those data and come up with the understandings on it. So data science does not require coding or computer science background, because nowadays you have plenty of tools already available from Google, from Microsoft, from RapidMiner, IBM, and all that. So you don't have to know coding at all.
Okay. Another question is, machine learning is not just if-else statements, but rather depends on the amount of data fed into it. How then does the machine learn?
Oh yeah, that's what I would say, that it's a how would machine learn. I would give you a quick understanding. Uh, just try to understand when you were a small child how you learned how to make a A. You used to create 3 lines, then you have to create dots, right? Then you join those lines, and then you write a A. Similarly, that's what your brain is training your own neurons, that this is how joining these two dots you can make a A. Similarly, using data, they are predicting the patterns, how your brain has developed that pattern. After 10 years, you don't require lines or dots to make a or B or C, right? That's what machine learning is doing. How it is doing? It's a statistical models which has been developed way ago, where they have different models which are probabilistic and all that, where you can go a bit deep dive. There are tons of research available. So that is the basic understanding how machine understands using data.
Okay. So we have another question asking about the difference between classification and clustering.
Classification and clustering. Okay, so classification, understand as you want to just classify between. Okay, you have you go to the some shop where you have a section where bananas and apples all are together messed up, right? You want to classify whether this is a banana or this is an apple. So you are basically dividing into a two groups, categorical, whether it is a or B. That's what classification is all about. Okay. Clustering is basically you want to understand, say that you want to understand all the people, all the like-minded people who are into the research domain. So you want to create a cluster, you want to create a group which have a similar attributes, similar characteristics. Characteristics can be that they are doing research together into same field, or characteristics can be multiple as well. So you are grouping into multiple parts. And classification can be supervised and unsupervised as well. So unsupervised, you don't know what you are grouping. You come up with groups, then you try to understand what this group means. Who are these people which has been classified in these groups, on what basis they are.
Okay.
Yep.
Another question is about, as a data scientist, how are you handling data security and data protection in real time or while training?
Yeah, that's a very, very good question, actually. So, talking about Funnel, as Funnel is also developing products, which is also helping uh, various VCs and all that. So we basically make sure that data governance policies are implied. We are able to mask data. We have proper data protection officers, so who can protect the data, who can mask. So basically, if we are dealing with data, we are dealing with anomalized data. We don't get to see who are exactly those companies are. So that can be done using masking, or using the APIs, where you can create different machine and different servers, which is sitting on so the whole data sits on different servers, which has been encrypted and masked, and nobody has the access to it.
Okay. So there is another very frequently asked question from the audience, that is, can you take masters in data science without bachelor's in computer or any related field?
Yes, you can do it. I would say that enterprise business analytics and data science is very co-related field. And if you see how many people are going in that field, you would see an architect going into that field, a doctor going into that field as well. So why they are doing masters in data science and they are coming from different field? Because they understand that data can provide their services better, so they can use their skills into their domain. So architect can use data science to have a better designing and constructions, and he don't have to go anywhere. He can use data to get all the dimensions and all that. Using data, he can get that. Doctors can predict diseases based upon print, because human has a limited understanding. We don't remember all the things, all the cases, right? So using data, they can create some models which can help them to do their day-to-day life. When I did my master's, I had people coming from law. I had people coming from social science background, arts, media as well.
Okay, that's very heterogeneous
Yeah.
people coming together to learn data science.
Yep.
Okay. So another question is, what differentiates data science from statistics? How big does data need to be big data? And how is all this implicated in machine learning and AI?
Okay, statistics is the backbone of machine learning. All the machine learning models are a statistical models only, which has been already created. So you don't have to know deep dive into the statistics itself. What is important is understanding of those uh, domain, understanding the data and how the statistic can help you. And another question was?
How big does data need to be called big data? And how are these implicated in machine learning and AI?
Big data, okay. I would give you a small example of how data becomes big data. Once your laptop or your database takes a long time to process and compute is big data. When you collect data in different shapes and sizes, it's not structured, it is coming in text side, then it is a big data, and you need computing power to process it on the cloud or in the servers. That's why you go towards the big data side. And deep learning also comes into that side where you have big data and you have deep learning to help to compute those analysis.
Okay. Another question says, can you tell more about machine learning techniques used in finance, for example, trading portfolio optimization?
Okay. Creating portfolio optimization, that can be done in various ways. That would depend upon how much data you are collecting and all that. Let me give you an example how data is being used in financial. Let's take my own company example. So we get companies, private companies which are started from seed round to series DEF, and they come up with their resume of the company, so pitch deck of the company. So they come up what the company do, who are the founders, what is the background of the founder, what is the business model, what is the USP, and the financial reports and all that. So that's the financial data what we get. So we have our own proprietary scoring system which helps to furnish a scorecard, a health index, that whether this company is potential enough to move for the further due diligence or not. So we are trying to evaluate, and using that is helping investors to diversify their portfolio as well, right? Because they want to understand in which sector they want to dig into, and that sector has a potential or not. So market and industry performance come into the picture. Then you need to understand, say that there's a company, uh, we had a company like Coffee Meets Bagel. You need to understand how they are different from Tinder. What is the difference between those two companies, how their business models are. And that is how you can understand the competitive landscape. And based upon that, it won't be a single model. If it is, then it won't be very generalized. It has to be multiple models. So coming together and creating the whole platform, and you might have to go a bit rule based if you don't have much data. If for funnel we started with rule based, we moved to predictive, we moved towards the AI, the whole of the multi-model part. Yeah.
Okay, so I'll ask you one last question. What do you look out for when hiring data scientists or interns for your firm?
I only look for the person is dedicated. He has good concepts. He has integrity, and he understands what is given to him. So understanding at a human level, understanding at the data level is important. So analytical skills is the key. We had few interns who didn't knew Python, who didn't use databases. They are currently learning it, but we want a person who is willing to learn. That's something what we look for. Who is always wearing a student hat, even he is an intern or he's at the company. That's important.
That's right. The process of learning is never ending, and no matter how much big position you acquire, you always continue to learn.
Yeah, definitely.
Okay. So thank you, Akshay, for the talk. And I'm sure it has been very helpful for all the students and all rest of the attendees. We had a lot of questions, but because of the time constraint, unfortunately, we cannot answer all of them. So we'll try to answer all of your questions. You can either reach out to Akshay on LinkedIn or via his email ID. And before leaving this session, please make sure to fill the survey form that is indicated as a QR code on your screen. And to remind all the NTU students who need seminar attendance, please remember to fill this form. So thank you. Thank you, Akshay. Thank you, everyone, for joining.
So much.
Thank you.